science author. I'm not going to steal a lot of this thunder because he's got a good interesting story to tell us tonight. He has, as I learned this afternoon, he has a background in both science and in writing. So he's got a BSc in physics, as well as he managed to pull off a degree in English at the same time. And as you'll hear, has written a number of very engaging science books. This fits very much within the spirit of the Science Speaker Series, in which we try to show the broad value of scientific education and outreach. And I'm really excited to have Sean stand with us here tonight. So please join me in welcoming Mr. Kean for Lakehead University. Just a couple of things that I should say in terms of housekeeping. I've not taught this room for a while. I can't remember where the bathrooms are. I know there's some down the main stairway. If we escape here this way, I think, and down, we can get to the loading dock. Just in behind the Starbucks? Just behind the Starbucks. This way. That one goes out to the bathrooms out this wing here. The cafeteria. Okay, and this is the fastest way to get to the exterior of the building as well. Okay, anyway, please join me.
Well, hello everyone. Thank you all for joining me this evening. Can you hear me in the back? Is that good? Okay, good. So I had a bad go of things in about third grade or so. I came down with strep throat something like a dozen times that year. And each time I did, I got to stay home from school, so it wasn't all bad as far as I was concerned. But, I wasn't feeling good. I was feeling kind of achy, kind of fluey. And my mother was kind of fussing over me. And so she would often try to take my temperature with one of those old-fashioned mercury thermometers that you can see in the picture here. And I admit I was a little clumsy when I was a kid. I was also very prone to talking to myself when I was a kid. And so often as not, my mom would stick the thermometer under my tongue, try to take my temperature, and the phone would ring, whatever, she would leave the room. I would start babbling to myself, something would happen, and not infrequently, this would happen. The thermometer would fall onto our hardwood floor and it would shatter, and the mercury would go spilling out of the end of the thermometer. But I always admit I was kind of secretly excited when that happened, because I loved watching the little bits of mercury go spread all over the floor like that. There was like these little liquid ball bearings everywhere. And my mother was actually very cool about the whole thing. She never panicked, she never made us evacuate the house or anything like that. She would actually get down on her hands and knees with a toothpick, and she would start to brush the little spheres of mercury toward each other. And my favorite part was when she had two little spheres right next to each other. And I'd kind of be looking over her shoulder, kind of watching her. And then she'd give them one final nudge, and then they would jump together into this slightly larger sphere that was perfectly seamless. And I just thought it was the most amazing substance I had ever seen in my life. I mean, it's a metal, it's heavy, it's dense like a metal, but it's very shiny like a lot of metals are not. Also, it's a liquid, so you can play with it. And I was just blown away by this stuff. And I managed to accidentally break enough thermometers over the years where we had quite a nice collection of mercury. And if we'd been good that day, my mother would take it down from this little shelf she had it on. She'd let us play with it, like whisk it around a little. So I really had a lot of nice memories of this metal mercury. And so when we got introduced to the periodic table for the first time in school, maybe even roughly about that same year, the first thing I did was try to find mercury on the periodic table. And I looked top to bottom, looking all over for mercury, and I just couldn't find it. I just did not see mercury on there. And of course, mercury is on the periodic table, but the symbol for mercury is Hg. Neither of those letters are actually in the word mercury, though, and so I thought, well, boy, that's kind of stupid. Why would that be the symbol if those letters aren't actually in the word? So I looked into it a little more, maybe help from my teachers, parents, whatever. And I found out that, the symbol Hg, it actually comes from some old Greek and Latin words. And I thought, I didn't know they knew about this metal thousands of years ago. And in fact, not only did they know about this metal, but it was incorporated into their culture in sort of wider, various ways. For instance, there was a god that they associated with this metal, with mercury. Also a planet that they associated with it. And the more I looked into it, the more I realized that, wow, Mercury really does have this long, rich, interesting history. Alchemists, for instance, were obsessed with mercury. They were always using it in different sorts of experiments, heating it up and the fumes go all over dangerously, but they were obsessed with it, thought it had the secrets of the universe. When they were colonizing the New World, they would ship whole galleons full of mercury over because it's very good about sucking gold out of other ores and things it's mixed with. So they used mercury for gold and silver mining. There was even a bit of a connection to the exploration of the Midwest, the middle of the continent. So I am from the Midwest in the United States. I'm from South Dakota. And so we always had a very long Lewis and Clark section in our local history classes, two very famous explorers who kind of explored the middle part of the continent. But there was one story about Lewis and Clark, these explorers, that they didn't teach us in school involving the story Mercury. And the reason why they didn't teach us will probably become obvious as the story goes on. So this story gets started with one of the so-called founding fathers of the United States, a man named Dr. Benjamin Rush. He signed our Declaration of Independence, was part of the revolutionary movement, that whole thing, in the 1770s. But during his day, he was actually better known as a physician, as a doctor, and especially when he stayed behind during a yellow fever epidemic that erupted in Philadelphia in the 1790s. So it's a deadly fever. A lot of other doctors basically just fled the city, abandoned their patients. But Dr. Rush very bravely stayed behind and treated a lot of people who would not have gotten treatment otherwise. Unfortunately, though, Dr. Rush's pet treatment for pretty much any ailment was this mercury chloride compound he would kind of force feed them. Often until their hair started falling out, their teeth would get loose and fall out, they'd start drooling from the side of their mouths. One of the things going on in medicine at the time was that there was a lot of fraud. Like they were selling things that didn't have any active ingredients in it. So a lot of people, when they were buying a medicine, they wanted to know that there was something in it. There was an active compound in it. And when the people had the mercury medicine, they sure felt something. I mean, they knew there was an active compound in the mercury. So they knew they were getting their money's worth. So they thought this was really great medicine. And obviously it's not how we think about medicine nowadays, but that was kind of the reasoning that they were using back at the time. So anyway, Dr. Rush thought these pills were, or this treatment with the mercury was fantastic. So he ended up mass producing them, producing patent pills. Each was about 4 times the size of an aspirin, so very, very large pills. And he ended up packing 600 of these pills with the explorers' party as they went wandering through the wilderness. And there's really no delicate way to put it. These mercury pills were extremely powerful laxatives. They called them thunderclappers. And the idea was, if anyone in the party ate something they shouldn't have, or drank some questionable water, something like that, they could pop one of these pills and it would basically flush them out, clean out everything in their system. Mercury is a poison. Your body does not want it inside you, so when you swallow it, it goes through you very quickly, gets those bad things out of your system. And we know that Lewis and Clark must have used these pills, and in fact we know that they must have worked quite well, because they have had a bit of a side benefit for historians and archaeologists today, in that they can actually still pinpoint a few places where they know Lewis and Clark must have stayed, because the level of mercury in the soil is just too high for it to have been natural. So from this one element then, from just mercury, I learned some unusual exploration history, but I also learned about etymology, learned about chemistry, learned about alchemy, mythology, poison forensics, little planetary science. Just a whole bunch of things seem to be wrapped up in this single element, mercury. And that's really how I think I got interested in science for the very first time, was when I would hear these stories about things like different elements on the periodic table. And in fact, when I was going through school, high school and later college at the University of Minnesota in Minneapolis, when I was going to school, I always took all the science classes I ever could. And even more than that, I gravitated toward the teachers and professors who would tell these kinds of stories in their classes. I loved hearing all of these science stories that they had. And so when I studied science in college, as I said, I was a physics major. And when I thought I was going to be a scientist for a very long time, but about my junior year or so, something kind of swerved on me, where I noticed I wasn't enjoying the classes as much as I had before. And the lectures and things, the stories, things we were learning were fine. It was kind of the labs that were killing me a little bit. Often things like this would happen in the lab. I would drop something and it would break. Again, I was pretty clumsy, maybe should have seen some foreshadowing with the thermometers there, but I just wasn't very adept at manipulating things in the lab, so that could be very frustrating. But the other thing I realized was that even beyond any clumsiness on my part, was I just wasn't enjoying the labs in the way that other people were. Other people loved tinkering with things, building their own equipment, testing it, doing all these sorts of things. And I just didn't like that. I found it very, very frustrating. And so for the first time in my life, I started to wonder, well, do I want to be a scientist? Do I want to do something else with my life? And it was kind of a scary moment for me, in that I had really never considered doing anything else with myself. So I almost felt kind of empty, like I didn't know who I was anymore if I wasn't going to be a scientist. And I found out later that, that's actually a very common thing for people going to college. They start with a subject, they think they like it, they get into it, they think, maybe it's okay still, but maybe it's just not something I want to dedicate my whole life to. So what I decided to do, I still kept going with my science major, but I kind of ran to the other end of campus and started to get an English major at the same time. So I was kind of working on both tracks there. And I did enjoy the writing, the reading, all of those sorts of things you do with an English major. But eventually I kind of missed the science aspect of it. And eventually realized that writing about science would be a good way to marry those two interests. In that I could keep learning about science, keep talking to scientists about their work, but I didn't have to be in the lab all the time. And I didn't have to specialize the way you do when you are a scientist. So I worked at some newspapers, some magazines, things like that. And eventually realized that what really interested me was learning about the history of science and writing books about it. That turned out to be a much better medium for the kinds of things that I wanted to do, which was to tell stories about science and the history of science. And so in 2010, I came out with my first book called The Disappearing Spoon. And it kind of had its origins in those Mercury stories I was telling you. In that the premise of the book is to find a funny or spooky or weird story about every single element on the periodic table. And I did manage to cram all 118 elements in there. Some of them just make a cameo here and there, but all of them do make an appearance at some point. And overall, there were really two motivations for me writing this book. One of them was, I don't know what your experience might have been in chemistry classes, but I was always really frustrated that we never talked about just whole huge swaths of the periodic table. I mean, there were so many elements that just never, ever, ever came up in class. And so I wanted to know, what are the stories behind those elements? I wanted to write stories about them and give them their own individual personalities. So that was one motivation. But another motivation was that I knew there were actually really great stories out there about elements everyone thinks they know pretty well, but that if you look into their backstory, they do have a rich, unusual history that you might not have expected. And probably the best example of that, of an element with a hidden, unusual backstory, is the element aluminum. Or do we say aluminium here? We do, we say aluminum there? Okay. All right. Just wanted to check. So the element aluminum. So, of course, we all know aluminum today. It's in, pop cans, Little League baseball bats, aluminum foil. It's kind of a throwaway element, one we don't think about too much. But believe it or not, for a long time, during the 1800s, aluminum was actually the most precious metal on Earth. It was worth far more than silver was, worth far more even than gold was. And the reason why is that even though aluminum is very common, it's the most common metal in the Earth's crust, out in nature, aluminum is always very tightly bonded to another element, usually to oxygen. So in other words, aluminum is always in a mineral form. You can't go out and find like a mother lode of pure aluminum somewhere. You have to get the aluminum off of the oxygen atoms, and that's very, very difficult to do. And so when scientists in the very early 1800s started to get the first pure samples of aluminum, it was considered kind of a miraculous metal because it was very light, but also very strong, very attractive. It basically had everything you would want in a metal. And because it was so hard to produce aluminum, it became something of a status symbol for kings and emperors to get their hands on aluminum trinkets. So right here, you're looking at an aluminum centerpiece that was created for one of the emperors of France. And that is aluminum on the top, and then that's gold beneath it, because aluminum was the more impressive metal. So obviously, you would want that on the top. Another emperor of France also had this prized set of aluminum cutlery that he reserved for his most favored guests at banquets. And the lesser nobility were actually reduced to eating with gold knives and forks. And it was considered very embarrassing to be seen eating with the gold knives and forks when there was aluminum silverware available. And even some other countries got into this game a little bit. I love this story because right now I do live in Washington, D.C. in the U.S. And if you've ever seen our National Mall there, there's a monument we have called the Washington Monument. It's basically an obelisk, kind of a large, very skinny tower sitting there on our National Mall. You can go to the bottom, kind of look up, gawk at it. You can go inside it even if you're so inclined. But when the U.S. was putting this up in the 1880s, as you can see right here, the government decided they were going to put at the very tippity top of that monument a 6-inch pyramid of aluminum. And they did that for a couple of reasons. One, if you've ever seen a picture or maybe been down there, you know the Washington Monument is standing there all by itself. There is nothing else around it. So they knew lightning was going to strike it at some point. They needed a metal at the top as a lightning rod to conduct electricity safely down to the ground. But the reason they chose aluminum out of all the other metals they could have chosen was that the government was kind of bragging a little bit. They were saying, you know, we are such a powerful up-and-coming country that we can afford to put aluminum on our public monuments. Isn't that impressive? And there were a lot of places that were very impressed with this. For a while, because not long after that, the aluminum market crashed completely. What happened was a few chemists, a couple of European chemists and an American chemist, figured out how to mass produce aluminum on an industrial scale for the very first time. And there was one chemist in particular, the US chemist, a man named Charles Hall, who figured out how to do this very efficiently and very quickly. And probably no one ever made more money more quickly on their knowledge of the periodic table than Charles Hall did. So he discovered this process. He actually worked on it as part of his undergraduate thesis project, figuring out how to make aluminum. Figured it out when he was just 23 years old. They called him the Aluminum Boy Wonder. And not long after that, he founded a company. It's now called Alcoa, Aluminum Company of America. And when he was starting this company, he was shipping out about, I think it was about 50 pounds or so of aluminum, about 20 kilograms or so, every single day. And that was plenty to meet demand. Just 20 years later, he was shipping out roughly 90,000 pounds of aluminum every single day. He could barely keep up with orders. And a similar sort of revolution took off in Europe as well. Aluminum spread very, very quickly and became one of the most important industrial metals of the age. And I like this story because it gets me thinking a little bit. Was aluminum better off back then, when it was one of the more precious metals on Earth, but really no one had access to it, and few people had even heard of it? Or is it better off nowadays, when it's one of the more productive metals on Earth, but it's a little bit passé? We don't really pay much attention to it. It's kind of a throwaway element. You could look at it both ways, whether it was better off then or better off now. And the other thing is, I like this story because it goes to show that the fortunes of the elements do really change, over time. And it makes me think, what elements nowadays that we think are so important are we going to, not think are very important in the future? Or conversely, are there elements nowadays that no one pays attention to, but that people are going to be making a lot of money on in the future? The fortunes of the elements really do rise and fall over time. And that was the overall point of this book, was to get us thinking about these questions about individual elements, but also to show that they really do each have their own personality, and they all played a different role, whether it's in politics, war, construction, economics, all of these different things. The periodic table really does intersect with all of those different areas of our lives. So again, that was the first book, The Disappearing Spoon. And then a couple of years later, I wrote a second book called The Violinist's Thumb. And this was a book about genetics, about DNA, biology, things like that. And like my first book, I really consider it a story book. Someone actually noticed, I'm very impressed you noticed, that the DNA molecule is actually backwards, isn't it? Yeah, they noticed right away, I can tell. Mistake on the cover there, the DNA molecule should be inverted and going the other way. So this book was again a story book, where I wanted to tell stories about the human genome, human biology, human DNA, through the lens of our genetics, our genes. And to me, I think the most amazing thing about genes and DNA is that they're kind of this universal theme in life, meaning that no matter what creatures you're looking at, they have genes, they have DNA that work in the same basic way. Whether you're talking about tulips, guinea pigs, bacteria, toads, toadstools, slime molds, dung beetles, politicians, whatever. Genes and DNA work the same way in all of these bizarre creatures. And I just thought that was fascinating. That's the one thing that really unites all of these different forms of life. And again, it's the unifying theme of all of biology. But as soon as I started looking into this book, doing some research for it, I noticed that there was one thing in particular that's strikingly different about the genes and DNA of other animals and the genes and DNA of human beings. And the thing that is strikingly different is the names of the genes, the names of the stretches of DNA that do things in our body. Because if you've ever read a paper about a human gene involved in a disease or something like that, you might have noticed that they often have these long, horrible, jargony names. There's often random numbers or Greek letters in the middle. It's really hard to even parse what those words mean on a basic level. Like, they're just really ugly, off-putting names. But when it comes to animal genes, animal DNA, scientists have a little bit more leeway. They can be a bit more creative, they can have a little bit more fun. And in particular, let's skip ahead a little. In particular, I'm thinking about the genes of these guys right here, the fruit fly. Now, they might not look it, they probably don't look particularly witty, but they have actually inspired more creative and unusual gene names than probably every other animal out there combined. So there are different fruit fly genes named Groucho. There's one called Smurf, Lost in Space, Fear of Intimacy. There's one called Tribble, after those fuzzballs on that episode of Star Trek that start multiplying all over. There's the faint sausage gene. I have no idea what the faint sausage gene does, but it's a good name. There is the Tin Man gene. And if the Tin Man gene gets mutated, fruit flies do not develop a heart. So that kind of makes sense. There's a gene that leaves fruit flies exceptionally tipsy after a tiny, tiny sip of alcohol. It's called the cheap date gene, so that kind of makes sense. Probably my favorite gene name, though, was not originally discovered in a fruit fly. It was first discovered in a mouse. And this gene name was the POK erythroid myeloid ontogenic gene. Now, at a glance, that is a perfect example of a terrible gene name. Well, it's kind of hard to even understand what those words mean unless you're either a scientist or maybe even a specialist in this field. But if you look a little bit closer there, you see the first three letters are POK, and there's an E, and the beginning of the next word's an M. It kind of spells out Pokemon. And in fact, the scientists who discovered this gene, they named it the Pokemon gene. They published a paper where they called it the Pokemon gene, and it therefore became the official name of this gene. And so everyone had kind of a good laugh about this silly little acronym, the Pokemon gene. Except, you can see right after the word Pokemon there's a little R with a circle around it, which means copyright restricted. And the lawyers at Pokemon Inc. were not very amused about this, because it turns out that the Pokemon gene contributes to the spread of cancer in mice, and they kind of understandably didn't want their cute little pocket monsters confused with tumors. So they threatened to sue the heck out of these scientists. They were really going to take them to the cleaners over this, until the scientists finally backed down. And they gave it some other terrible gene name after that. But for one shining moment, there was actually a Pokemon gene out there. So with books, with my books especially, something people often want to know is, why did you pick the titles that you did? You know, this is a book about genetics. Why is it called The Violinist? It's an obvious title for a book about genetics. So I thought I would explain a little bit about the title and kind of the reasoning that went into the title for this book. So there is obviously a violinist involved in this, a man named Niccolo Paganini, usually considered the greatest violinist who ever lived. He was active in Europe in the very early 1800s, and you know, every king, every queen, every emperor wanted Paganini to come play for them, because he was the absolute best musician around. In fact, he was so good that there were always rumors floating around behind him that he must have sold his soul to Satan in order to get his talent, because no one could be this good unless they had the devil actually working and helping them out play the violin, because it just wasn't possible he could be this good. Well, you know, that probably wasn't the reason why he was so good. And in fact, one of the non-fiction reasons why he was so good, we think nowadays, is that he had these amazing, even sort of freakishly flexible hands. So one thing he could do with his hands was he could put his hands, or actually, I'll say this one first. He could take his pinky like this, and he could bend his pinky into a right angle with the rest of his hand just by stretching it out and going like that. So it actually gets worse, because he could also put his hand down flat on a table, on a surface like this. Then he could raise his pinky and his thumb behind his hand, and he could actually touch them behind his hand just by going like that. So he could do things with his hands you should not be able to do with your hands. And it wasn't just his hands that were amazingly flexible. He could actually bend his elbows the wrong way, his knees bent backwards. He was kind of like a circus rubber man. And based on clues like this, it's almost certain that Paganini had a genetic disorder of some sort that affected his connective tissue. And we know of other disorders, like when you see a circus rubber man or rubber woman like bending themselves into different shapes, they probably do have a connective disorder of tissue similar to something that Paganini had. And this actually helped him out his music a lot, because he could stretch his hands incredibly wide. He could do fingerings that no one else could do. So he could play music no one else could do, and he could play it faster and better because of these amazing hands that he had. And I like the story as a title story for a couple of reasons. One is that we normally think about something like genetics, a hard science, being on one end of a spectrum, and something like music, a fine art, being on another end of a spectrum. They're kind of at the opposite ends. But in this case, if you know a little bit about the genetics, know a little bit about the music, you can actually see there's a very nice connection between the two things. You can actually, they reinforce each other. Knowing something about one helps you understand the other, and vice versa. And I really like doing that with my books and these stories, is making those connections between things you wouldn't think to connect. A science topic and a fine art, politics, different things like that. So it does do a nice job of illustrating that, I think. And the other reason I like this story as the title story is that there's a good scientific lesson in it. In that Paganini, he did have these amazing hands, sure. But he was also a very hard worker. He loved playing and practicing music. And he grew up in a time in early 1800s Europe where violinists were some of the greatest artists around. They were the rock stars of their day. So the reason he was so amazing wasn't just his hands. It was his hands, his genetics, but also his temperament, his environment. All of those things working together made him the amazing musician that he was. So it wasn't just like he had these amazing hands and poof, suddenly he was an amazing musician. A lot of different factors were playing in. And if you talk to scientists nowadays about genetics, where the field's going, what they're trying to do, they do often talk about things like gene-environment interactions. It's not just genetics that make us who we are. Genetics are important. They definitely influence us, and they influence our mental traits. But they don't determine who we are. There's a lot more to it. There's our environment, our temperament, a lot of different things play into that. And so if you want to know where the field is going, you have to take these gene-environment interactions into account. And Paganini is kind of a nice little package where you get all of that wrapped up in one story. So for those reasons, it's why I chose it as the title story for the book, The Violinist's Thumb, because it kind of brought it all together and really showed where the field of genetics is now going in the future. So again, that was my second book, The Violinist's Thumb. And then a couple of years after that, I published a third book called The Tale of the Dueling Neurosurgeons. And, people often ask about the titles of the book. Another thing they often ask is, why did you write this book? There are thousands of scientific topics out there. Why did you choose to write this topic about neuroscience when you could have chosen 1,000 other topics that were out there? And I can say that with this book, the reason I chose this topic was doubt, or skepticism, mistrust, whatever you want to call it. Because a few years ago, I was reading a story about a man who got injured in one part of his brain, and his behavior shifted in this very unusual way. And I was reading this story, and I said to myself, that sounds like bullshit. I just don't think that actually happened. I think the author probably made a mistake about the details of what they were writing about here. So I kind of forgot about it until about a week or so later, reading another case about an injury, this time to a woman, and again her behavior shifted in this very strange, very specific way. And I thought to myself, that story cannot be true either. And so I kind of set out to prove these authors wrong. And of course, I ended up looking stupid because they were right and I was wrong. But I couldn't let these stories go. They just kept going through my head over and over, and I kept thinking about them. So what kind of stories were these? Well, I think we can all generally recognize what types of animals we have in the picture here. But it turns out that there's a spot in the temporal lobe on the side of the brain, so near your temple. There's a spot in the temporal lobe, a very specific spot, where if that spot gets damaged, then all knowledge of animals will disappear from your head. So these people can still tell different types of plants apart. They can tell human faces apart, human-made objects, those are no problem. But dogs, elephants, raccoons, fish, they cannot tell these creatures apart. They just cannot distinguish one from the other. And there's another spot very near there. If that specific spot gets damaged, all knowledge of plants can disappear, while they can still recognize animals okay. So it seems we have these very specific modules in our brain for classifying and recognizing different types of plants and animals. And if you think about our evolutionary history, having this kind of makes sense. In that, think about our ancestors wandering through the savannah or whatever, the jungle, they would have seen different types of plants and animals. And those people who were good at recognizing them and saying, okay, this animal's dangerous, stay away. This one's good to eat, this one's a good companion. Or different plants. This one's a good medicine, this one's poisonous, this one's good to eat. People who were good about recognizing and classifying them had an advantage, ended up producing more offspring. Eventually, this ability sort of got hardwired into our brain, and we are all the beneficiaries of that nowadays. The only downside to having this sort of hardwired bit in our brain is that if that part gets damaged, then poof, that knowledge can disappear. And that seems to be the sort of thing that's happening to these individual people. And the second story about the woman that I mentioned, I thought was even more unusual, even crazier. So this woman was having trouble speaking. She was having trouble producing language because of some brain damage. And unfortunately, sadly, that's a very common thing for someone to suffer brain damage and then they can't get the words out of them anymore. They just cannot produce them. They cannot speak anymore. And one very common area that does suffer damage and that will impair your language is the Broca's area, which I've highlighted in peach there. A very famous part of the brain involved with producing language. If that gets damaged, you're going to struggle to speak. However, in this woman, something slightly different was going on. In that her Broca's area, that part by itself was actually okay. That was undamaged. What was damaged was the part that connects the Broca's area to her mouth. So if you think about it, the Broca's area is up in the brain, it's producing words, producing language, but those signals have to get sent to our teeth, our tongue, and our lips to actually move them. And in this woman, so basically it's like biological wires. Like you can imagine wires going. It's neurons, nerve cells, but basically biological wires connecting the brain to the mouth. And in this woman, the Broca's area was okay, but the wires were damaged. The wires were broken. It was like somebody just cut the wire and the signal could not get through. And so she was having trouble producing language, having trouble speaking. But one thing you learn about the brain as soon as you start to study it is that there are a lot of alternative pathways for information to move about inside the brain. There are detours, there are back alleys, lots of different pathways. And it just so happens there's a pathway that runs from the Broca's area of the brain. It goes into the limbic system, which is involved in emotional responses. And then the emotional centers of the brain can still get in touch with the mouth through one of these back alleys, through one of these detours. So that back alley connection was still there, even though the direct connection was broken. So if you started talking with this woman, just trying to have a conversation, everyday conversation, she just couldn't get the words out because the direct connection was broken. But if you got her mad, got her riled up, started to provoke her, and got that alternative pathway going, you made her mad enough, she could swear at you, no problem at all. She'd say, you beepity beep, and then sort of jump back. Because in a lot of cases, this woman didn't realize that she could produce these words. She didn't think she could produce any words. And then all of a sudden, her emotional centers of the brain were sending these signals down, and they were bubbling up out of her. Something similar can happen with the musical centers of the brain, in that the direct connection can be broken, but there might be an alternative pathway through the parts of the brain that process music, and they might be able to get in touch with the teeth, the tongue, and the lips. And these people, they can't speak in conversations, but they can sing song lyrics, no problem at all. There was actually a famous case in the United States of a congresswoman there, this is a while ago now, but she was giving a speech in Arizona when she got shot in the head. And she was one of these people who lost the ability to speak, but she could still sing song lyrics. And there were videos of her, she's in rehab, and she's singing songs like, "Girls Just Want to Have Fun." And I don't know why, Cyndi Lauper, out of all the songs, sort of stuck in her head, but by practicing singing, she was able to rehabilitate herself to some degree and learn how to actually speak again because of these alternative pathways in the brain. So these stories can tell us not only about, our evolutionary history, but about how we can rehab our brain and, brain science nowadays. They have something to say about brain science nowadays. And kind of the premise of this book overall was to look at a lot of these different case studies. People who suffer brain damage, they might have infections, they might have strokes, all sorts of different damage that damage different parts of the brain. And as different parts of the brain go down, you see people who have very, very specific deficits. And every time you get a specific deficit in one specific spot of the brain, you can say, aha, that part of the brain must be involved in producing language. This one's involved in recognizing different types of things. This one's involved in memory, in vision, all of these different things. And basically, the entire history of neuroscience until, a couple decades ago, when we got fancy MRI machines, things like that, was basically these case studies, these people who suffered injuries, and we had to learn about how the brain worked through these people's lives and how they were dramatically changed in one moment because of these injuries. So basically, it's a collection of a bunch of different stories of what we can learn about the brain through these people who suffered sometimes great tragedies in their lives because of these injuries. But I thought I would wrap up a little bit, just kind of talk about basic things there like language, vision, stuff like that. I thought I would wrap up with a little bit talking about kind of higher level things that neuroscientists are just getting a purchase on nowadays, the higher level functions of our brain. And this story actually is centered in Canada. Took place about 5 hours or so away from Vancouver. There was a young woman there, about 2005, who got pregnant, found out she was having twins, actually. And so she was very excited. She went to the doctor, was getting a sonogram, it was kind of late in the process, and the doctor said, I'm very sorry, I have some bad news. The twins are actually conjoined, what used to be called Siamese twins. And the woman decided to have them, decided to bring them to term. And as you can see here, the twins are actually joined at the head. They basically have a Siamese brain. And I should say the two girls, Krista and Tatiana, they are still both alive today. They're fairly healthy, they're happy, they go to school. This story turned out probably about as well as it could have. It could have been something where one had a lot of brain damage and like that, but it turned out pretty well for these girls, and they're living a fairly normal life overall. But because they do have this connected brain, they do show some unusual behavior. And now in particular, the part of their brain that's connected is a part called the thalamus. And we all have a thalamus inside of our brains. It's basically a relay center for sensory information. So information comes in through your eyes, through your mouth, through your ears. The first stop it makes is the thalamus. And the thalamus decides, okay, what kind of information is this? Okay, I'm going to alert this part of the brain and this part of the brain. So it takes in sensory information and it relays it to different parts of the brain. Now, because these girls share a thalamus, in a lot of cases they share sensory information. So, I mean, what does that mean specifically? Well, it turns out that if one of the girls is, say, taking a sip on a cup of juice, her sister can actually taste the juice in her mouth. You give one of them a shot at the doctor's office, the other one will grab her arm in pain. You tickle one of them, the other one starts to laugh. They fall asleep together. They maybe even dream together. And scientists have never seen anything like this. And the girls are still pretty young. They're still only 13 or so. So they haven't done a lot of studies on them because they're not really old enough. They're kind of trying to let them have a mostly normal life. But they do bring up, even this sort of little we know about that, they do bring up some very kind of deep questions. And kind of the most obvious big question that I can think of is, they're sharing sensory information. Sensory information, what we're paying attention to, is a large part of our consciousness. And so, are these two girls like individual people, or are they kind of one larger person if they're sharing a brain on some level? And maybe there's not a good answer. Maybe there's no clean-cut answer. But I do think that most of the evidence points to them being individual people, even if it's anecdotal so far. So one thing, for instance, is that the girls often walk up to somebody and one of them will say something like, I am just me. And the other one will pipe up right away and she'll say, I am just me as well. And that's kind of an odd thing to say. Like, no one here would walk up to somebody and just say that to them. But it seems like the girls do feel that they are individual people and apparently need to define themselves as individuals. So they do feel like they are individual people, which should count for something, I think. And the other anecdote I think is even more revealing. Is that one of the girls likes ketchup. She loves ketchup on her hot dogs, on her fries, everything. Unfortunately, her sister really hates ketchup and is always kind of like scraping her tongue when her sister eats it because she can taste it in her mouth. And it's kind of a slightly humorous story, but there is a lesson there in that the girls are getting identical inputs. They're both getting the same sensory information, but they're reacting to it in different ways. Same inputs, different outputs. They're reacting like individuals would. And so again, I think most of the evidence points to them being two separate individual people. And stories like this, and a few others that I talk about in the book, really get into high-level questions about the nature of the self, the nature of consciousness, all of these big, high-level things we can study in some degree when we see unusual cases like this, of brains that have developed in unusual ways, that have injuries, that you can see kind of consciousness changing, things like that. Neuroscientists are getting a little bit of traction, at least, on these big questions that philosophers have been arguing about to not a lot of productivity for thousands of years. Neuroscience is finally getting a little bit with there. Maybe we'll get far, maybe we'll solve the problem, maybe not, but we are starting to see a few insights based on these unusual cases. So they still are important today. So overall, those are my books. And I did write a fourth book called Caesar's Last Breath. I won't really get into that now. You can ask about it if you feel like. But overall, those are my books and kind of a feel for what I like writing about, the types of things I like writing about. But I have to confess I've been sort of tricking you a little bit on some level this whole time. And that I've been telling these sort of stories about different things, about a violinist, about the twins, different things like that. But actually, I suspect you did learn a little bit of something along the way, about genetics, about how the brain works, something like that. And then, again, that's really what I try to do, is tell these stories about scientific topics to help you learn that and to kind of slip it in on the slide. Because the human brain really remembers information best when it's presented in a story form. We're very bad at things like numbers, dates, tables. We're terrible remembering that information. But if you have a main character, if you have conflict and drama and villains, we're very good about remembering and absorbing those things. Even if it's a scientific story. In fact, maybe even especially if it's a scientific story, we're better off remembering it when we have those stories that kind of anchor it for us. So I hope you can walk away tonight with a new appreciation for both science itself, but different ways of thinking about science, getting science across to other people. So again, thank you all for joining me this evening. I appreciate it. I think we have.
So there's certainly time for questions.
Okay.
And on your way in, you notice that there are some books that Sam graciously will sign. You'll need to purchase a book, or he'll happily sign a book for you. So we'll answer some questions, and I know we have some refreshments outside as well. So I'll kind of field questions, or
Okay.
for you.
You were saying about damage to the temporal lobe, that they cannot recognize animals. Can that be re-taught, or is that permanently gone?
All right, so he asked about the temporal damage and whether they can maybe relearn to recognize animals. And it depends a little bit on the person. Like there were some people who visually they could not recognize animals, but if they could touch them or something, they could say, "Oh, okay, I understand now what it is that I can touch it." Some people could hear them as well, so they did have some recognition. But there were some people who just were oblivious to it. They could not do everything. And for those people, they can probably learn some context clues. Like if you go to somebody's house, it's not going to be probably a gorilla there. It's probably going to be a dog or a cat or something like that. So they can pick up and learn to work around it in some ways. But I don't think it actually ever came back from these people. Yeah.
Just to follow up to that, it came in my mind when you were talking about it. If it's an elephant versus a cat, they're going to visually see that this is something larger than this thing beside it, but there was just no reference point for them.
Yeah, it's just like we see an elephant, we're just like, okay, we know that's an elephant.
Yeah.
And for them, they would have to think about it and be like, okay, maybe it's big and it's gray.
So it could be, yeah.
Yeah. It just doesn't come to them the way it comes to us. But there are cases they could probably, depending on where else they had damage, they could probably piece it together. But
And if somebody told them, like, this is an elephant, they would understand that?
I think that depends a little bit on the person and whether they would have, because the temporal lobe is also involved in memory, storage, and retrieval, things like that, among other parts. So I think that would depend a little bit on the person, whether they had lost, maybe they didn't remember anything about elephants. Maybe just all that knowledge was gone. They didn't have access to it. So it kind of depends on the person.
I can see why you were skeptical when you first read it.
Right. But yeah, there are papers, neuroscientific papers that they have gone through and done tests and things like that. I see, I'll go with you.
It seems that we live in a time where certain segments not small segments of the population in various parts of the world, not just mistrust science, but don't believe it.
Like south of here?
Well, it's not exclusive to just south of here. And you write about science, so any insights on how better to communicate so that people will not have that absolute disbelief and mistrust in what science has to say?
Yeah, a little bit. I don't have to deal with a lot of it directly. I think it's sort of a self-selecting thing in that no one who really mistrusts it would probably come to a talk or would pick up a book in the first place. So I don't get to deal with a lot of it. But I have read other things about beliefs and things like that. And in a lot of cases, from what I can tell, people who are rejecting evidence, they are doing it because their social groups, basically, are also other people who reject those kind of things. So they're doing it to kind of conform and fit in with a group of people. And if you want to approach them individually and you sort of bombard them, that's probably actually going to backfire and make them just dig in their heels, basically. Because emotionally, they will see that as an attack, not just on them, but like on their entire group. So if you want to get those sort of things across, it's important to maybe not explicitly acknowledge them, but sort of make sure you're taking those external factors into account and not just thinking about this is evidence, you have to believe it because it's evidence. If you really want to change someone's mind, you need to go a little bit deeper and think about, you know, their psychology, their sociology, some broader things, which is harder. It's not an easy thing to do, but I don't think that there have been studies where you just tell somebody information, they often dig in their heels and don't like it. So having some of that context, keeping that in mind, and trying to work with that or work around it, I think does help.
In your books, you describe some scientists who, for lack of a better term, have really big personalities. Of all the scientists, from the incredibly conceited to the almost outright crazy, which one did you find the most fascinating?
The most fascinating scientist. I can answer that a couple of different ways in that if you'd ask me like what scientists I would want to like meet and have dinner with or something like that. I think Ernest Rutherford is someone who comes to mind. He was such an amazing scientist. I love the work he did. He was a boisterous, fun personality. He seems like someone I would really enjoy and get along with. The most fascinating, I think, is probably Isaac Newton. But maybe not for the reason that a lot of people know, in that we all know the one side of Isaac Newton. He, theory of gravity, invented calculus, theory of colors, did all of those amazing things. But he actually did all that work in roughly a year or so of his life, and then spent the rest of his life doing alchemy experiments and hunting for hidden codes in the Bible about when the apocalypse was going to come. So Isaac Newton sort of like he did the science very quickly and then spent the rest of his life doing things that we would think or look absolutely crazy nowadays. And I just think that's a really fascinating mix to think about someone who is such an amazing mind, just really one of the few people who truly revolutionized the world, but he almost didn't care about that work. His real work, he thought, was these other things that he was doing. So just to know that someone like that kind of existed, I think is sort of fascinating. Go to you. Yep.
One of the things that really strikes me about all your books is that you take an incredibly eclectic group of stories and people and history and ideas, and you weave them together in a coherent way. So I was wondering about your research and writing process, because I can't imagine how you begin to start a new book and how you decide what you're going to include, what you're going to exclude, and how you're going to put it together in some sort of coherent narrative. So can you comment on just how you manage that kind of size of information and get it down to a book that sort of makes sense and is readable?
Yeah, so we asked about the research process and like how to cull all the information and bring it down, basically. So one thing I think is that the first thing I do is I ask, is there a story here? That's really what I focus on. It might be an interesting topic, it might be an important topic, but if I can't get a story around that, then I'm going to struggle probably to introduce in the book. I need to fit it into a story somewhere. So knowing that there's a story there, I think, is the most important thing. And then it's just, there are a lot of things you cut out, but I just think about what stories excite me, what stories would I want to tell people. There are some stories out there that are kind of interesting, but they're really not going to live up to it, or they're kind of a distraction, something like that. So I think it's just a matter of, I guess, kind of practice in recognizing what will make a good story, and then then I guess the other important part is actually finding the stories and doing the research. And that there's really not a magic solution to it. It's just really a matter of sitting down in libraries and just reading a lot. Hunting through footnotes, following 3 or 4 papers as their footnotes kind of trace you back. Going to archives and doing, looking at original papers and documents, things like that. So, I mean, on the one hand, it's good that there's no magic solution to it. Like, you just have to work. But on the other hand, it is work. So it's not the best answer that you want to hear, but it is accessible to anyone if you just kind of do the work. And then it's a matter of figuring out what tales you would want to tell other people, what would get you excited, things like that. But you do end up cutting a lot out, unfortunately. Let's see. Oh, yeah.
I'm intrigued by your theory that Paganini's virtuosity is attributable to his unusual hands and his connective tissue problem. He left 5 violin concertos, 24 caprices, and a handful of other pieces, which many violinists have played since and do to this day. Like, I think he just advanced violin playing in the same way that Liszt advanced piano playing.
Well, when they grow up...
Why do you attribute it to this unusual thing? I mean, if a violinist can get his hands around the star...
Well, those other violinists probably grew up playing it as well, so they were able to do some things with their hands. As well, they get practice basically stretching their hands. And there's no guarantee they were as good as Paganini was. I mean, he was considered the greatest when when violin playing was at its peak. So.
But we have people like Jascha Heifetz, for example, who was probably the violinist of his day, and now even people like Michael Ennis, Canadian violinist. I'm sort of intrigued that you're saying what you're saying about that.
Okay, but a little skeptical. Okay, that's fine. Yeah. My guess is that they probably, from children, grew up playing it and grew up kind of playing those things that had to make them work and use their hands in ways like Paganini does. Whereas for him, it was sort of natural to be able to do those. Whereas his peers really couldn't have done those things because they didn't grow up trying to do those things, basically. So knowing it's available, having practice, doing it from a young age, I think would help as well.
Thank you.
You mentioned at the beginning that you enjoy talking to scientists, and then you also mentioned going to the library. So I'm just wondering, where did you get either inspirations or sources of what material for the stories?
The inspiration or the source material, it does come from a lot of places. Sometimes it's reading just like a paragraph in a book, and you say, oh, okay, that sounds interesting. I want to know more about that. So I'll jot that down for later. Sometimes it's just something a scientist says kind of offhandedly, or sometimes you are talking to scientists about one story and they mention something else, you end up pursuing that. So there's really not 1 or 2 sources or anything like that. Like if I went through and sort of footnoted where everything came from, it would probably just jump all over the place like that. Probably do one more. Okay.
Are you working on anything now?
I am, and I should say if you are feeling shy or you think of something, I will be signing books, so I'll be available out there as well. But yes, I am working on something now. So this book will probably be out next summer, next July. And the premise of this book was that during World War II, the Manhattan Project to make the atomic bomb, there were a bunch of refugees from Germany, scientists who got run out of Germany by Hitler. They came over to work on the Manhattan Project in North America. But they were convinced that Germany was far ahead of us on atomic research and was working very hard on building the bomb. Because Germany had the best scientists in the world, a bunch of Nobel Prize winners there. They had discovered atomic fission there in the first place, and they had amazing industry there as well. So they were convinced that they were going to make a bomb for Hitler, going to hand it to Hitler, and he was going to destroy the world with it. So these refugee scientists, eventually helped convince the leaders of the Manhattan Project to send this sort of undercover scientific commando team into Europe to spy on and sabotage and even try to assassinate members of the German nuclear bomb project. So the book is about those people that they sent in and the work that they were doing in Europe at the time. And so there were a bunch of great characters in there. There was like an ex-Major League Baseball player who could speak 12 languages and turned into an atomic spy later. Our President John Kennedy, his older brother, was actually involved in the project and died during kind of a peripheral arm of this project. So a lot of great characters in there, kind of an overlooked part of the Manhattan Project. And it was a really fun, cool book to write. So.
Yeah, you got inspired by learning about it.
Learning about it, hearing about it, and seeing that I'd seen pieces of it in lots of different places, but nowhere that had kind of brought it all together like that. So, it'll be called something like the Bastard Brigade, because that's what they call these fellows running around.
Sounds like a big screen.
I hope so, if you know someone.
Anyway, that was a really good segue to wrapping up the presentation this evening. So, on behalf of Lakehead University, the Faculty of Science, and a couple of other folks who helped pull us together, again, thank you so much, Sam, for your presentation tonight. From
All right, thank you.
And as we said, there are some refreshments outside. Please join us and stay for that. He'll be available for continuing conversations and book signing. We do this a couple of times a year. I don't have a speaker for February, but stay tuned. At the Research and Innovation Week, that'll be our second speaker for the year. Anyway, thank you. Good evening.